Is there a 3D printer built for real production and prototyping but priced for a home workshop? Well, kinda. This is the HeyGears Reflex 2. It's built for real work, but it's priced a lot less than other industrial printers. But that lower price comes at a cost. Is it worth it for you? Let's find out. This isn't just a printer, by the way. HeyGears has their own whole ecosystem. They use their own software, they use their own resins, they have their own wash and cure station. Everything is designed to work together, and you should use them together. You could probably get away with a different wash and cure station, but maybe you shouldn't. We'll talk about that later. And yes, that does mean you're locked into their resin ecosystem. There are pros and cons to that. We'll get to that later. First off, what makes this thing industrial exactly? Industrial, it's one of those words that, like heavy duty on a pickup truck, like it doesn't really mean anything. You know, you can park a heavy duty pickup truck next to a big rig. Which one's really heavy duty? What would you expect an industrial machine to do versus like a hobby one? Well, the industrial one should be able to do more specialized work continuously for longer without breaking down. And the Reflex 2 seems to be designed entirely to do just that. It has some of the biggest dual linear rails I've ever seen, one of the chunkiest lead screws I've ever seen. This build plate is so heavy, you could probably hold up a heavy duty truck with it. And if you drop it on your foot on accident, you will be getting x-rays. It has a fancy segmented light source, so it only lights the areas that are needed. That cuts down on heat, which will shorten the screen life, especially if the machine's just running continuously all day. There's this pulsed release module, which helps the prints peel off of the release film faster. That helps it run faster. It helps prolong the life of that release film, and it allows the Reflex 2 to print more highly viscous, like engineering resins. And it's designed to reduce user error related damage. There's an auto leveling system that runs before you print, and that checks if there's anything left in the vat. If you've done a lot of resin printing, you'll know that that's a surefire way to very quickly wreck a release film and even break screens. This won't let you do that. A lot of printers have that feature, I know, but a lot of printers don't. And you know, anything to prevent downtime is a good idea. This scraper is a much less common feature. It mixes the resin while it's heating and while it's running. It can also move chunks of things out of the way if they fall off the build plate. This is an optional metal one that also heats the resin. A lot of resins, especially the engineering ones, need very precise temperature control. And this will stir the resin while heating the resin directly. There's a lot of different ways that resin printers will heat the resin, either through like the vat will have heaters around the sides, or there'll be a light source underneath that just turns on. But this system is very interesting because it directly heats the resin itself and nothing else, while mixing the resin to make sure it's nice and even. Very clever feature. I've only had this for about a month, so I have not needed to do this, but supposedly these parts are also designed to be easy to change. That's kind of a big deal, especially with industrial machines. Parts will wear out eventually if you're using it all the time, and you will need to be able to maintenance the machine. Okay, so the hardware's there. Is it easy to use? Any standard nerd like me can make pretty much any machine work, but if you're in like a shared makerspace or an office, like an engineering office, and you have different employees with different amounts of printer knowledge, or maybe you're just new to this and you don't know what lift speed or dwell time means, that's okay. Maybe you don't know how to support models. That's fine. I can hear the people in the comments typing away saying, Chit2Box isn't that hard. And you're right, I agree with you. Unless you have no idea how resin printing works and you've never seen it before. Blueprint, which is the name of HeyGears' proprietary slicing software, it's very easy to use if you have no idea how resin printing works. A total newbie could go from no prior knowledge to printing stuff by lunchtime. And that's in part because of this closed ecosystem. They have their own resins and they have their own software. They have tight quality control on the resins, which means they can program in the settings ahead of time and know that that bottle will work on your printer. You don't need to know how to calibrate anything. You can be sure that the resin you put in there will just work. So can you make your own profiles if you want to use other resins? No, you can't. I'll talk about that at the end. But first, let's go over some of the resins they do have available. This is PAH 270. It's a high heat, high hardness resin. To me, it feels higher density than the other resins. It's a bit heavier. They say it's for functional parts in hot environments like car engine bays or molds for injection molding, something like that. I don't have any plastic injection molding equipment, but I do have some metal, some that melt at a low enough temperature that's roughly similar. I printed a 2-part mold and poured in some tin bismuth alloy, and it held up just fine. You know, 3 of these parts back to back, no damage at all to the mold. This is a very low temperature metal. It melts on par with ABS plastic, actually. I didn't try any hotter. The resin's only rated for 270 Celsius. But even with this stuff, normal resins tend to warp so badly that the molds will open up and the metal will all leak out. But this one held up just fine, and you can actually see the layer lines in the finished coin. I also printed out this nut and bolt. This is important because cheaper consumer resin printers tend to warp everything. Things don't get too dimensionally accurate. This exact nut and bolt model tends not to thread together off of most printers. This one threads perfectly. I haven't had to do any cleanup at all. Mechanical parts are no good if they don't mesh together properly. This one did it perfectly, and keep in mind, I didn't have to mess with any settings. It just did this the first time. And here's a die, a D6 die printed in this same resin. You can see as I measure different faces and orientations here, it only varies by about 20 thousandths of an inch, and that's on a 16 millimeter cube. It's maybe not casino grade flawless, but it's pretty good. Definitely good for use in prototyping mechanical parts, or even, this feels nice and heavy if you want to print a bunch of these for some reason. This resin has some specific curing requirements. It's got to be baked at 80 Celsius for an hour and then cured at 60 Celsius for an hour, I believe. And this is where the HeyGears curing station is a must for that. Then there's this resin called PAE10. It's very elastic. Think like silicone rubber kind of feeling. I printed off a few straps, O-rings, seals, a few of those rubber bump stops that are like on the end of shelves and on the end of drawers and stuff that always fall off and you always need more. Now I have endless of them. I even made a foot for my shop stool. Neat. Now I need 4 more. Man, this bench is messy. It's grippy. And this RC car tire. This is hollow. I bet you could play with like rigidity and stuff, but with different amounts of infill and all that. I just printed one because I thought it was neat. No baking is required for this, but you will want to cure it in like a cup of water. That'll prevent it from getting tacky. Next up, PAT10, a transparent modeling resin. It's clear, it's also a little bit flexible. In my experience, most of these clear resins are actually pretty brittle. This one passes the comb test. I print a little clear comb and I try to bend the tines. Most resins are either too flexible, you can't actually use it as a comb, or they're stiff enough, but if you bend the tines, they just snap right off. This is a pretty good middle ground between the two, and it didn't snap. And none of these clear resins are perfectly clear when they're straight off the printer. But this one is pretty nice. It's pretty good looking. And when it's thick, it takes on a nice, pretty bluish color, like this fish here. This print is actually a failure. It's supposed to be a fish with like a head and everything, but I kept it because the resin looks so cool. I had other print problems with this resin. When I told them about it, they immediately went away to revise the profile. And they rolled that updated profile out to everybody. That means everybody got that update with the updated profile. There's a lot of other resins like this wax resin designed for jewelry casting. I got a bottle of that, but the profile wasn't available for me to record this. When it becomes available, I will do a review of this resin on my metalworking channel called Paul's Garage. I'll link that at the end. So if you're a jeweler and you're thinking about maybe getting this machine, go check that out. So far, I've only talked about a few examples of their engineering resins, but most of these resin printers seem to be used for very detailed miniatures. At least that's what they're marketed towards. And you can use the Reflex 2 for that, but I'll cut to the chase. If you like the HeyGears software, which is pretty nice, and you like the HeyGears modeling resins, which is also really nice, but you only make miniatures like for your home hobby, they have a printer for that. It's called the Reflex RS or the RS Turbo. Go check that out. I got one of them over there. It does everything that this one will do for miniatures. You can't print the flexi silicone modeling resins or the casting resins or any of that, but it's a lot cheaper and you can put the money that you save towards a bunch more resin. With that out of the way, let's look at some miniatures that I printed with this because it gives us some good data. I mentioned it with a nut and bolt, but precision is key with a lot of this stuff. Here's a tank and turret printed in some $15 resin on a very good consumer printer. The turret doesn't even fit. The resin looks overexposed because it had to be in order to hold together. The model had tolerances enough to fit, but the print itself warped and it will no longer go together without a little bit of sanding. And here's another tank and turret, this time shrunk to 50% and printed on the Reflex 2. When you shrink something by straight 50%, you also shrink all the tolerances by 50%, which makes warping more of a problem. And yet, this turret fits on just fine. Resin printers also tend to have problems making flat surfaces actually flat and making holes that are nice and clean. And this had zero issue whatsoever. All the parts on this model fit, which is very impressive. The detail is also very impressive. Most printers advertise somewhere how good the resolution is, and it's measured either in a screen K number, which is meaningless, or a pixel size number. How big are the pixels? Smaller pixels are obviously better resolution. I believe the resin and the settings play a more important part. In fact, this has pixel size of 40 microns, which is not that great compared to a lot of other consumer printers out there, which are these days sub 20 microns. I'll cut to the chase again. I would ignore that. I took a very detailed tiny model from a company called One Page Rules and I shrunk it by 50%, printed it again. And you know what? It still printed out all the details, but smaller. The detail on this thing is better than my eyesight, and anything better than that isn't really that important, especially for industrial things. If all you're printing is super highly detailed tiny things like miniatures for painting competitions or whatever, I can kind of see an argument for that. But if you're printing industrial stuff, this is way better resolution than you will probably ever need. In fact, there's maybe 2 printers I've ever used that are arguably more capable than this one, and they had worse resolution than this one, and they printed just fine too. So in my opinion, trying to find the best resolution printer just doesn't matter. What does matter is how prints are supported. When you print things in complex shapes, especially like these miniatures, they have to be supported. That's the scaffolding coming up off the plate that's holding the print in place. When you download files off the internet, a lot of times they will come in supported and unsupported files. If you're making your own, like if you're designing something, CAD software will give you unsupported models. Unsupported is the key word there. All slicers can generate supports, it's true. But in my opinion, Blueprint arguably does the best job of it. They're the easiest to remove. They leave the least amount of damage on the part itself. You get little bumps instead of divots. It's very cool. In fact, it's so good, I would say if you have supported models available, don't use them. Take the unsupported ones and let Blueprint do it for you. They will come out better. Yes, I ran tests for this. I had multiple models that either failed when they were pre-supported on this and other printers, and then came out perfect with Blueprint supports, or at least they came out better with fewer issues when I use the Blueprint supports. The one thing I do pay attention to is part orientation, because whichever part of the model has the supports connected to it will leave little bumps. And sometimes you can move it and adjust the orientation of the part in a way that either hides the bumps or puts them in a place that don't matter or that are easy to remove. And now, the elephant in the room, the closed resin system. You must use their resins. They don't even have an open mode that you can buy or anything. There's no unlock for this. I expect that will ruffle the feathers of many hobbyists out there. And I hear you. I agree. It would be nice to have an open mode. But the resins that I've tried from HeyGears are so good that I kind of don't want to use a different resin. There is an argument to be made that third-party modeling resins especially can be cheaper. That's true. But HeyGears has a PAS 10, which is an extremely good model resin. It's like ABS tough, and it's really detailed. It's great. And it's like $33 a bottle. And yes, that's not the cheapest, but it's also really good for $33 a bottle. When it comes to the engineering resins that the Reflex 2 specializes in, the HeyGears stuff is actually on par or even maybe a little cheaper than some of the third-party resins out there. So I don't really see the cost savings benefit there. That being said, I would like to see more options. They are releasing more resins over time, like this PAH 270 here. At time of recording, that's not even on their website yet, but it just goes to show they are making new resins that are pretty cool, though their resin library for the engineering stuff anyway is kind of limited. So the question, is the Reflex 2 a good printer for the price? Yes, if you are printing more than just miniatures. Unless you're mass producing them or something, like for sale, then you might want to think about this machine. I would say if HeyGears offers an industrial resin that fits your needs and you don't have a massive industrial budget, the Reflex 2 is a fantastic choice. Definitely get it with the wash and cure station too. I didn't go over those in too much depth, but the wash station is very unique. It sloshes everything around in a bucket, which is kind of neat. It drains the resin into another bucket without you having to reach your hands in there. And it's got a little tiny screen that stops even the smallest parts from falling through. That is the main thing I hate about the majority of wash stations out there. Any tiny little parts fall right through the mesh. This never happens. It's very cool. The cure station too, it has the baking and curing settings that you need, especially for these industrial resins. Just a standard box full of UV or even setting the stuff in the sun will cut it for model resins. They will not cut it for a lot of this industrial stuff. I'll put a link to where you can find this stuff in the description below and in the pinned comment. Go check it out. And if you want to see the metal casting resin used in a little more detail, I'll put a link to that other channel down there as well. I'll see you next time.